uh, is another topic in the chemistry. We call it test for gases. Test for gases. So these are the gases we want to see how we can test for them. Hydrogen gas, chlorine gas, oxygen gas, ammonia gas, hydrogen sulfide, SO2, CO2, and NO. How do you test for all these gases in chemistry? How do you test for all these gases in chemistry? So let's start with hydrogen gas. We want to start with hydrogen gas. Test for hydrogen gas. Hydrogen gas gives a pop sound with a lighted splint. It gives a pop sound with a lighted splint. You know, in the lab, if you want to prepare hydrogen in the laboratory, we normally use, let's say you have zinc here, then plus dilute HCl. That's what you normally use to prepare hydrogen in the laboratory. To form zinc chloride plus hydrogen gas. So the gas given off here is hydrogen. Any hydrogen is involved. Then you look for a splint. It could be a broom like this. Then with a fire or flame, that's the splint. Lighted, is known as a lighted splint. A lighted splint. So what you'll be hearing is pop, 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 pop. It will give you that sound. That pop sound is a result of a hydrogen gas is reacting with oxygen, atmospheric oxygen. It's now forming water. So at the end of the day experiment, you see a droplet of water here. Water droplet here at the open end of the tube. These are called water. So pop sound is a result of a formation of water. That's how to test for hydrogen gas. Another thing is we want to see oxygen gas. How do we test for oxygen gas in the laboratory? Oxygen gas. You know oxygen? It rekindles a glowing splint. It rekindles a glowing splint. As it supports combustion. I support combustion. Now, take note of this. Other gases that rekindle or support combustion, like oxygen, that support combustion, like oxygen, nitrogen 1 oxide, the one we call laughing gas, and HNO3 vapor. All these support combustion as well. Like for HNO3, why does it support combustion? NH3 can decompose to water, NO2, and plus oxygen. It is this oxygen that then supports combustion. So this is a chemical test for oxygen. Chlorine gas, Cl2. That is chlorine gas. How do we test for chlorine gas? Chlorine gas turns starch iodide paper blue-black or black. That's the chemical test for chlorine gas. You know starch iodide paper? Starch iodide is a paper soaked in starch and potassium iodide solution. Let's say it's soaked. You now use chlorine gas, starch iodide paper. Then what is in starch iodide paper is potassium iodide in chlorine gas. So there can be a displacement reaction where you have potassium chloride then plus iodine gas. You notice we have mentioned that under starch. Anytime iodine come in contact with starch, it turns blue black. That's why it will turn it blue black. Iodine gas then reacts with starch and a blue black coloration is observed. This is the chemistry of reaction. That is a test for chlorine gas. So let's see test. This is test for chlorine gas. So test for ammonia gas. This is ammonia gas. This is test for ammonia gas. How do we test for ammonia gas? Ammonia gas is the only basic gas in chemistry that turns moist red litmus paper blue. It turns moist red litmus paper, meaning it is basic. The only basic gas that turns moist red litmus paper blue. But it forms a dense white film with ACl, meaning hydrogen chloride gas. It forms a dense white film with hydrogen chloride gas. So this is the chemistry of reaction. Ammonia gas plus ACl gas, hydrogen chloride gas, to now form ammonium chloride. This is X. This is a dense white film. That is dense white film. Meaning the formula for that dense white film is ammonium chloride. This is the chemical test for ammonia gas. If you want to test for hydrogen chloride gas, then you use ammonia as well. This test is equally used to test for hydrogen chloride gas. When hydrogen chloride gas reacts with ammonia gas, a dense white film is obtained. So if you want to test for ammonia gas, look for hydrogen chloride gas. If you want to test for hydrogen chloride gas, look for ammonia gas. This is the chemical test for ammonia gas and hydrogen chloride gas. Let's see test for hydrogen sulfide. Test for hydrogen sulfide. So hydrogen sulfide is a rotten egg smell gas, meaning its odor is we call it rotten egg odor or smell. That's the odor of hydrogen sulfide. So how do we test for hydrogen sulfide? It turns lead 2 ethanoate. It turns lead 2 ethanoate, meaning PbCa3COOH and COO bracket 2. This is lead 2 ethanoate. So it turns lead 2 ethanoate solution or paper. If you are using solution, fine, or paper blue black. Turn it black. How? We have lead 2 ethanoate CaCa3COO bracket 2, that is aqueous. This is led to ethanoate solution plus hydrogen sulfide gas. So it will form, the reaction will form lead 2 sulfide, and as you know in chemistry, lead 2 sulfide, iron 2 sulfide, they are black. This is black precipitate plus this hydrogen, lead 2 sulfide. This hydrogen will come back to Ca3CO to form ethanoic acid, Ca3COOH. Ca3COOH. This is COOH. This COOH. So this is ethanoic acid. Ethanoic acid, acetic acid, ethanoic acid. So this is black precipitate you are going to have. So this is one of the tests for, we can use another test for hydrogen sulfide by using KMnO4, by using K2C acidified KMnO4 acidified K2Cr2O7. Let's see other tests. So let me call it test 1. This is 1. Let's see the second test under hydrogen sulfide. You can use acidified KMnO4 solution. Acidified KMnO4 solution. It is purple. Then what about, how do we use it? Acidified KMnO4, hydrogen sulfide gas reduces or decolorizes acidified KMnO4 solution from purple to colorless with yellow precipitate of sulfur, This is another fine test for hydrogen sulfide. So let me give equation of reaction. We have hydrogen sulfide gas plus KMnO4 aqueous acidified, then plus A2SO, you add A2SO4 to it. When A2SO4 is added, then it will form an liquid is acidified. This is what you have. How do you form this equation? K will go to SO to be K2SO4 1, manganese 7, we turn to manganese 2, we go here too, we have manganese 2, tetraosulfate 6. This one is colorless. Manganese 2 is colorless, while manganese 7 is purple. So this one has gone here, this one has gone here. Then KMnO4 is a powerful oxidizing agent. We remove hydrogen, leaving sulfur plus sulfur. That is yellow precipitate. Plus this one remain hydrogen here. This one, hydrogen has been removed. Then oxygen. Hydrogen will combine with this oxygen to form water. That's the equation of reaction. So it decolorizes from purple to color, from manganese 7 to manganese 2 with a yellow precipitate of sulfur. If you don't use that, we use number 3. Another thing you can use, we use acidified K2Cr2O7 solution. That's another reagent that can be used. And the color of this is a golden yellow or orange. Call it golden yellow or orange. Acidified potassium also dichromate 6. That's another thing you can use. How do we use it? Hydrogen sulfide decolorizes acidified to Cr2O7 solution from golden yellow or orange, golden yellow, or you call it orange to green with yellow precipitate of sulfur, with yellow precipitate of sulfur. That's another fine text. That's another text. If you want to form equation of reaction here, hydrogen sulfide gas plus K2Cr2O7 solution, then plus A2SO4 to acidify it. This is aqueous solution to acidify it. Then this one will go through the same thing. K we move here, it will be K2SO4 plus chromium 6. We turn to chromium 3. So chromium 3 CrSO4. It will give this 3. It will give this one 2. That is chromium 3 tetraosulfate 6. So the color of this is green. Chromium 3 is green, while chromium 6 is golden yellow or orange. Then plus this one will remove hydrogen. It's a powerful oxidizing agent, while it's a reducing agent. So it will, what is oxidation? Removal of hydrogen. So it will remove hydrogen, removing sulfur. So we have plus sulfur, which is yellow precipitate. Then plus what has gone here, it remains hydrogen here. Then oxygen is remain. Then to combine to form water. So this is the equation of reaction. These are the different texts for hydrogen sulfide. Another test we want to look at. We want to look at NO, nitrogen 4 and nitrogen 2 oxide. Nitrogen 2 oxide. Let's see nitrogen 2 oxide. NO. Under nitrogen 2 oxide, this one it reacts with a freshly prepared iron 2 tetraosulfate 6 FeSO4 solution. Freshly prepared iron 2 tetraosulfate solution. So how? FeSO4 to form a brown ring. So FeSO4 solution freshly prepared plus NO gas. So it will form FeSO4 dot NO. This is brown ring. This is known as a brown ring test. Also a brown ring test. This is to test for brown ring here. To test for nitrogen 2 oxide. Carbon 4 oxide. That is a CO2. CO2, it turns lime water milky. It turns lime water milky precipitate. It turns lime water milky. What is lime water? Lime water, take note, is calcium hydroxide. That is lime water. This is lime water, calcium hydroxide, plus CO2 gas to form a product. This is a chemical formula of lime water. When it contains a large volume of water, when a very small quantity, we call it a slaked lime. So lime water, it will be calcium carbonate plus water, It will be calcium carbonate plus water. This is known as a neutralization reaction because this is an acid anhydride, while this is a base. So this is salt and water. This is the milky precipitate. Meaning the formula for milky precipitate obtained is a calcium triazole-carbonate 4. This is a chemical test for carbon 4 oxide. But in past question, they said if you now pass CO2 for a long time, period of time, meaning in the presence of excess, calcium carbonate form plus water, these are the two products. Then excess CO2, meaning when you pass CO2 for a long period of time, so it will form a product which is a calcium hydrogen triazole carbonate 4. This is a clear solution, no precipitate, a clear solution. So the precipitate just disappeared in the presence of excess CO2. Basically, so this is the text that they ask in questions, past questions, what happen if CO2 is piped for a long period of time through lime water? It will form milky precipitate, but in excess CO2, when it is passed for a long period of time, it forms a clear solution, meaning precipitate disappears. This is another test for this is chemical test for carbon 4 oxide. Now we have seen test for hydrogen, we have done it now. Oxygen, we have done it. Chlorine, we have done it. Ammonia, we have done it. CO2, we have explained that. Hydrogen sulfide, we have explained that. That is 1, 2, 3, 4, 5, 6. NO, we have explained that. SO2, you normally have SO3 or SO2 and SO3, either of the two. You can test for that one as well. Under sulfur 4 oxide, sulfur 4 oxide and 6 oxide, sulfur 4 oxide, SO2. You can use this reagent. You can use acidified KMNO4, acidified KMNO4 solution, where it is depolarized by SO2. So SO2 decolorizes acidified KMNO4 solution. It decolorizes KMNO4 solution from purple to colorless without yellow precipitate of sulfur. So we have the equation SO2 gas plus KMNO4 plus water. You form an equation. You form the equation for this. This one, potassium will come to this. It will be K2SO4. It must take it to higher oxidation state. It won't stop at SO3, but SO4. Plus manganese will react with this MnSO4. This is purple. Why this is colorless. Plus this has gone. It will remain oxygen, water, and SO2. So it will form S2SO4. You can see the difference. Here is colorless, no yellow precipitate. Unlike hydrogen sulfide, it will decolorize it with a yellow precipitate or sulfur. The same thing here. You can use acidified K2Cr2O7 potassium heptazodichromate 6 solution. You know it to be golden yellow or orange. So SO2 decolorizes it as well. SO2 decolorizes, even SO3 decolorizes acidified K2Cr2O7 solution, potassium heptazodichromate 6 solution from orange or golden yellow, from golden yellow or orange to green. Take it to green. Take it to green. What is the equation without yellow precipitate of sulfur? So we have SO2 gas plus, this is gas, K2Cr2O7 solution plus A2SO4. To acidify it to form same equation, you have K2SO4 plus CrSO4 chromium 3, then plus water. This chromium will react with SO4, K2SO4. Potassium will react with that, chromium will react to that. So you are left with hydrogen, oxygen, and SO2. So you have to form you are left with oxygen and hydrogen to form water. This is the equation, and this color is green. So we've been able to discuss the gases that are very common in chemistry. How do we test for each of them? Please subscribe, like, share, and comment. God will bless you as you do that. Thank you.